Hello and welcome. This video is about Unicode approach to character encoding. Character encoding can be broadly classified into Unicode approach and non-Unicode approach. In this tutorial, I will focus only on the Unicode approach. The Unicode approach involves two concepts, the concept of code points and the concept of encoding code points. Let us now explore the concept of code points. There is a global organization called Unicode Consortium. It assigns unique integer codes to all characters which need encoding. The codes so assigned are called code points, and code points are usually written in hexadecimal base. The best way to understand code points is to explore some examples. Let us now see some examples of code points assigned to English characters and symbols. The number which you see below each symbol is the code point assigned to that symbol. If you are familiar with ASCII codes, you can see that the code points are exactly same as the ASCII codes. Let us now see some examples of code points assigned to currency symbols. Again, below each symbol, you can see the code point of that symbol. These are code points of some mathematical symbols. If you have guessed that the code points of each language lie within a certain range, then you are right. Let us now see the range of code points for some languages. The very first range that you see between 20 hex and 7F hex is for the English language. The script of English language is called Latin script. That is why it is mentioned as basic Latin. You should know that code points are allocated to scripts and not languages. That is because language has nothing to do with writing, and it is always the script which is used for writing. Let us now take a look at the scope of the code point allocation. 135 scripts which are used to write 782 languages have been covered so far. This includes all the important scripts of the world. All the currency symbols and mathematical symbols have code points. Common symbols such as arrows, emojis, traffic signs, and in fact even the restroom symbol have a code point. The code point of restroom symbol is 1F6BB in hex, and when this symbol is rendered it looks like this. And lastly, the lowest code point is, needless to say, 0, and the highest code point is 10FFFF. So, that was a brief introduction to the code points. Let us now explore the concept of encoding code points. The fundamental fact about code points is that they are not used directly for storing text. Doing so is not efficient. It is always the encoded version of the code points which are used for representing text. There are three Unicode character encoding schemes: Unicode Transfer Format 32, Unicode Transfer Format 16, and Unicode Transfer Format 8. In this tutorial, I am not going into UTF-32 and UTF-16. I will only describe UTF-8. When it comes to character encoding, it is almost enough, at least for the beginners, to know UTF-8. You should note that 88% of the websites in the world use UTF-8. I will now give an example of how UTF-8 uses the code point for representing a character. Sometime back, the Indian government introduced a new symbol for Indian rupee. The Unicode Consortium allocated a code point of 20B9 hex to this symbol. When this code point is translated to UTF-8, it becomes E282B9 in hex. When a computer program encounters E282B9, it looks for corresponding font and renders it. And when rendered, the symbol looks like this. I will now explain the actual procedure for translating a code point to UTF-8. This procedure is for code points below FFFF hex, and this covers the most important languages and symbols. Consider the code point range from 0 to FFFF hex. Subdivide this into three contiguous ranges. The first one from 0 to 7F, the second one from 80 to 7FF, the third one from 800 to FFFF. Note that there are no gaps between two ranges. This is a contiguous range. For all the code points in the first range, use a 1-byte template. For all the code points in the second range, use a 2-byte template, and for all the code points in the third range, use a 3-byte template. I will now show what these templates look like. So that is a 1-byte template. The second one is a 2-byte template. The last one is a 3-byte template. As you can see, some bit positions are filled and some are vacant. The filled bit positions shown with a lock symbol must not be modified. All the vacant slots must be filled up in a way that I will describe shortly. So one more time, this is a 1-byte template, and this is a 2-byte template, and this is a 3-byte template. Let us now see how to use these templates. Let us consider the code point 41 hex, and the corresponding binary version is shown. 41 hex lies between 0 and 7F, so this code point belongs to the first range. Therefore, we are supposed to use the 1-byte template. This is the 1-byte template. This is the given code point. Remember not to use the leading zeros. Copy the least significant bit of the code point to LSB of the template. Copy all the remaining bits in an orderly fashion, and that is it. We now have the UTF-8 equivalent of the code point 41 hex. Let us now list out the steps of the procedure. Step 1 is to choose the correct byte template. Step 2 is to express the code point in binary. Step 3 is to identify the leading zeros in the binary version. Step 4 is to copy the bits from the code point to template starting from LSB. Step 5 is to fill unfilled slots in the template, if any, with zeros. Let us now take another example wherein the code point belongs to the second of the three ranges. The code point is 5D0 hex, and the binary version is as shown. 5D0 lies between 80 hex and 7FF hex, so this example belongs to the second range. In this case, we are supposed to use the 2-byte template. This is the 2-byte template. This is the given code point in binary. Remember not to use the leading zeros. Copy the bit in the LSB position from the code point to the template. Copy the remaining bits in an orderly fashion. And that is it. We now have the encoding for the code point 5D0 hex. Let us now try a code point which lies in the third range. The code point is C85 hex, and the binary version for C85 is as shown. C85 lies between 800 and FFFF, so this belongs to the third range. Therefore, we are supposed to use the 3-byte template. This is the 3-byte template, and this is the given code point. Remember to discard the leading zeros. Copy the bits starting from LSB. Note that there are unfilled slots in the template. According to step 5, we are supposed to fill them with zeros, and so we have done it. We have the UTF-8 encoding for the code point C85 hex. So that concludes the tutorial. As always, I welcome your feedback. Thank you.